Okay, I'm gonna try another problem now. Let's get into it. Let's go on a random problem. Maximum width ramp. Cool. So a ramp in an integer array of nums is a pair I, j, for which I is less than j, and okay, nums I is less than equal to nums j. The width of such ramp is j minus I. Given an integer array nums, return the maximum width of a ramp in nums. If there's no ramp, return 0. Okay. So answer is equal to 0. Return answer. I guess we can just start off doing the brute force method. Thought process, brute force. It should be O of n squared, I think. And then we'll iterate through I to length of nums, and then j to I. Or we can go from I to length of nums, and then we go from j that goes, so I will go from 0 to length of numbers, and then j will go from I to 0. Right? There's probably a more efficient solution. We could do left and right pointers, I think. Why not? If we do left and right pointers, no, we can't do left and right pointers just because, like, yeah, I don't think we can do left and right pointers. It's an unsorted array, so you can't really, like, figure that out, to be honest. For I in range, length of nums, and then we go for j in range, we want to include I, and we go to 0. If, okay, so in all cases, we have established that I is less than j, right? If we go from I minus 1, yeah. Let's make this j and make this I, just so that it's better that we understand this. So j is the larger thing. Yeah, if nums I is less than or equal to nums j, oh, we want the maximum width, so we shouldn't iterate backwards. Yeah, we really shouldn't be. Yeah, we really shouldn't iterate backwards. This is so dumb. So we should just go until I minus 1. Well, no, just go up to I. Go up to j, I mean. Yeah, so in all cases, I is less than j, and if we have this, then answer is equal to max of answer in j minus I. And once we do that, we don't need to iterate anymore. We just now continue j. Right, so let me just do break, I think. So we break out of this for loop. Wait. In a nested for loop, does break exit both loops or just the inner loop? Oh, the innermost loop, cool. Yeah, so you break out of it and continue again, and then just return. So, I think this is pretty easy. Ooh, what did I get wrong? Does the break like mess up things? I guess the break did. How did the break mess up that loop? I'm not sure. There's definitely gonna be a time error. Runtime exceeded. This isn't the most efficient. Yeah, it doesn't. Yeah. So like, is the correct thing just continue? Alright, we're gonna get time limit exceed, okay. And why does break not work again? Ooh, okay, there has to be a better... There is a faster solution. So the solution has to be 2 pointers then. I mean, that's the only way, right? If we do 2 pointers, then we just go through like all the different possibilities. Okay, yeah, I think we have to recurse on all the pairs. And that's the best way we can do it. So base case is if L is equal to R, and we just return 0. Right? If nums L is less than nums R, we return R minus L. Else we have to recurse on L plus 1 and R, as well as recurse on L and R minus 1, right? Is that the answer? Okay. Oh, cool. Less than or equal to. Cool. Please be correct. Oh, wait, what? Why is it less? Oh, that's frustrating. I need a hint. Array stack, monotonic stack. Why do you want me to do a stack? So if you do a stack, then why do you want to do a stack? I don't understand. I'm not sure. Why do you need a stack? Why do you need a stack? Let's see. I want to see a hint. Any hints? No. What is a monotonic stack? Why do we need a stack for this? I'm not entirely sure. I think we have to ask ChatGPT. If you do a stack, then like I don't know what to add or what to remove, right? So if we not really sure. How to best solve this with a stack. What's wrong with my code? Your approach to solving the problem recursively is interesting, but has a couple of issues that make it inefficient. It is inefficient because you have a time complexity of 2 to the n and not n squared. recursive solution is O of 2 to the n. That's not that bad, is it? To solve this problem more efficiently, you can use a stack to keep track of indices of the elements in a way that helps in identifying the maximum width range. Here's how you can do it. Stack initialization. Traverse the array from left to right and push the indices onto the stack if the current element is less than the element. Traverse the array from left to right and push the indices onto the stack if the current element is less than the element at the index stored at the top of the stack. Okay, I'm not sure what this means. We traverse the array from left to right and push the indices onto the stack if the current element is less than the element at the index stored at the top of the stack. Why less? Don't we want more? Okay, anyways, so if we do that, this helps in maintaining the stack such that the elements indexed by the stack are in decreasing order. Okay, now we calculate maximum width. We traverse the array from right to left, and for each element, we pop from the stack while the current element is greater than or equal to the element at the index stored at the top of the stack. Calculate the width. Okay. Let's try the ChatGPT answer. What ChatGPT says. Okay, cool. I mean, if it's empty, so it's a peak. So previous index is equal to stack.peak. Is that a thing in Python? Okay, yeah, you could peak it. Cool. So we peak the previous index. If the current one, if the current element is less than the sums of previous index, we then add I. Cool. Now we calculate maximum width for I in range. Length of nums -1 to -1, right? And for each element, pop from the stack while the current element is greater than. Top of stack, so stack equals stack.peak, right? And then the current element is greater than or equal to the element that index stored at the top of the stack. Pop from the stack while the current element is greater than or equal to. If nums of I is greater than or equal to nums of stack index. We could just call this top stack. I mean, yeah, top stack. Then we have to call pop. So we call pop at the top of the stack. Answer. Oh, did I do this wrong? Cool. I understand that. While there's a stack and nums of j is less than or equal to, is greater than or equal to the other one, right? Cool. We just pop it. Yeah, stack dot pop answer is equal to max of answer and j minus stack. Cool. Okay. Okay, wait, okay. I understand this, but I may forget in the future. But it's an interesting approach to this problem, I will admit. Cool. Awesome, sounds good.